Welcome to Insight Builder channel, large language model enthusiasts, Python experts, and my dear friends. Turbocharge your prompts with Python processing. Learn and document 27 different data structures with 4 prompts. This is totally different from what you have seen till now in most of the other videos. Because we are actually teaching machines to solve problems, right? We have to get the machines to do our work and especially to solve the problems that we have, right? However, if you take a look at the scenarios, the problem that you're solving is that we need to get the LLMs, that is the large language models, to do our work. But the current scenario is LLMs are good at text generation, but they don't generate ideas. You can try it out. You can try to ask some couple of ideas on actually doing this particular task. That is to learn and document 27 data structures with 4 prompts, and you will find that it doesn't give you any of the actionable points that you can actually use. So I to me, learning is something different. You have to keep on practicing, and also you have to keep on referring to what needs to be learned. Prompting is repetitive. The second major problem with large language models, even including the best models in the market like ChatGPT or the Mistral group of models, prompting is repetitive. You have to repeatedly prompt if you want to get more information on a similar kind of topic, like 27 data structures. I'll be showing you all the 27 data structures and think about getting the information for all the 27 one after the other. That's going to be very repetitive. And the machines are not helping us. You are doing it manually, meaning you are not actually getting the machines to do your work. Even in this age, right? Data returned can be in different forms. This is something which you guys have already experienced, even with one of the best prompts, even with lots of different types of fine tuning. You will end up with data that is returned from the large language models, which is completely different between one prompt to another prompt. And even if it is the same prompt, if you try to request the data again, you will get a different output from the large language models. This is happening because large language models are basically auto completion engines. That's all. They are probabilistically giving the words out based on the questions or prompts that you are asking. So they're just auto completing your prompts. Okay. How to manage this and then get the best out of the large language models? That's what we are going to look at it right now. Apart from this, if you guys have seen my earlier videos, I have been working on this playlist of problem solvings from the machine perspective, and I've been introducing various concepts that is required for problem solving. And after introducing the functional to object oriented evolution of the programming languages, I started introducing data structures. I introduced lists as well as dictionary. These are the quintessential data structures that you have to master. All the methods, all the inner workings of this data structures, if you are able to work with, then we can dive into this particular challenge that we are working on. And this particular challenge that we're working on, I'm going to directly go into the demo right now. Just a second. So here are the 27 data structures that we are going to master. And all the data that you see here has been created or generated by the large language model, and it has been processed and placed into a format that is readable. So you see all these 27 data structures, it doesn't stop there. This is just the 27 data structures that you can select. So you can, if you want to understand DQ, you can select the DQ data structure set. If you want to understand about the set data structure, and as you scroll down, you can see the introduction. So when you're trying to learn about a data structure, you have to first of all get a basic introduction about what the data structure is made of, and what are the distinguishing factors or the features of that particular data structure, and then where, in what kind of problems this data structure, that is the set data structure in this case, is applied. So various applied problems are listed. Following that, the implementation of that data structure inside Python. This is where the large language models shine. All this code that you see here has been pulled out from the OpenAI API, and it has been processed in the backend using Python script, basic Python script. I'll be showing you. These are all basic Python scripts, and using basic transformations and data manipulation, you can get wonderful output. And there you see the implementation, the entire implementation as a class with its methods and also the example usage, all of these things. And finally, it takes one of the problems and it explains how we can implement the solution for that problem using the set data structure. All of these things in a single go, not just only for set. You can actually do this for any of the data structures that has been listed here, all the 27. So if you click on graph and if you scroll down, you'll see that you can get all the details about graphs. You can work on the applied problems of the graphs. You can see immediately that the way the problem is introduced here is little bit different. The format is different compared to the set. If you click on set, it will get updated, and if you scroll down, you'll see the applied problem here is 1 2 3 4 5, and it is in a single line, correct? But if you scroll up, if you click on graph, if you scroll down, you'll see here it is different. There is no 1 2 3 4 5 at all. There is no bulleted points. This is one of the major challenges you'll face in large language model, even though the prompts that are generating these outputs are still the same. This is one of the things, but even after that, you can actually create wonderful output. This particular app that you're seeing, we'll be seeing how to build this app step by step. So let's go back to the presentation. We were discussing about the problems that we are trying to solve, and you saw that the data is written can be in different form, but by using the processing, Python processing, you can actually remove the necessity to read, meaning you don't need to manually read all the output that is coming from the ChatGPT. You can actually generate a lot of outputs from the using your prompt engineering. However, you have to spend time reading it. You have to understand what the model is returning to you, and you need to process it again, and you're going to do it manually. That's a huge waste of time. Huge waste of time. So how are we going to improve that? For that, you will have to have the coding knowledge. You might think that you can actually ask ChatGPT to provide a way to process the text that you're having. Believe me, it's not going to work. It's going to give a very, very difficult way of getting the things done. And if you are not from the background of basic problem solving experience, then you are going to be at loss. I have seen people struggle with this particular aspect, but this is the reality. Artificial intelligence models or the large language models are just auto-completion engines. They are not ready to create ideas. They are not ready to be sentient. It's going to take a lot of time. Maybe in the future, maybe in another 6 months, another 3 months, who knows when. However, at this moment, they are not sentient. So you are not going to get ideas that is going to be groundbreaking. So idea is that we have to think. Humans have to think, and we have to use our brain, and we have to use our brain from the mindset that we have to get the machines to solve our problems. We have to teach the machines to solve our problems. So how are you going to teach that? By coding them. That is the only way. Storing, and finally, we have to store every token that has been received from the large language model, because you are paying for it. As simple as that. You are paying for every token that you are receiving, and why would you want to waste it? And important point is that most of the time when you're going to prompt something, you may not actually know whether it's going to give you a good result. But if there is a prompt which is working for you and you want to use that prompt again and again, it's better that you start using it right now and start getting all the data and place it in a location where you can easily access it. That is as a file. So all these things, in order to solve all these problems, there are only a couple of things you need. You will need an OpenAI SDK, that is the library, and its endpoints, and Python scripting knowledge. It's as simple as that. If someone says that ChatGPT can do the scripting. Yes, it can do the scripting. What I'm trying to say is that it will not give you the ideas that can make you work more efficiently and also get the stuff done really fast. So those things will not be there. Second thing, you have to get the basics of problem solving trained. It's very, very important. That is something that I would insist even in this particular discussion. So let us go back to the app for a second. So this is all the 27 data structures that you are seeing as a list here. You can play with it. This particular link will be shared with you guys in the description, and this is already available for everybody's to view. So it's already global, and the code as well as this particular JSON file that you see here is kept in the repo, Python DE-learners data repo. I'll be telling you why I had pasted this here after some time, but this particular data will be in the repo, and that repo link also will be shared with you guys. Now, with that said, let us go back to the presentation again. So here we have all the data structures that we are planning. So you have 9x3 matrix of data structures, and believe me, most of these data structures, I don't know how they work. The data structures that I am really fond of are queues, stacks, list, dict, tuples, not much. Strings, yeah, I like them. I love named tuples, and linked list, yeah, one of the favorites. Graphs, and yeah, not try is also one of the good data structures. And yeah, did not hear about Bloom filter till now. I was thinking it was some kind of a masking filter for some camera, but no, this is an algorithm. It's a data structure in Python. And a priority queue is also useful in certain cases when you are caching. Disjoint set, yeah, disjoint set is also one of the interesting data sets that you can come across. These are all data structures that I am fond of. I did not mean to say that they are important. Okay, these are data structures that is mostly used in many problems, and once you are comfortable with these data structures, you can start implementing them in your solutions. But for that, first of all, you need to understand how these data structures work. You can take a lot of courses, lot of classes, and do the same thing that you can do it with these 4 prompts, right? I'm not telling that it is a replacement for your courses or classes in data structures. No, not at all. The idea of using ChatGPT here along with the prompts is to create a kind of a handout, a notes for you, so that you can refer at a drop of the hat. Click on a link, look at the list of data structures. If you have any questions about a particular data structure, click on that particular data structure. For an example, default dict, if you have some questions, click on it, go down, look at the introduction, look at the problems that it is applied, and look at how it is implemented, and finally look at how an example problem. All these things in a single go. And if you have already taken any data structure course, then this should actually prime your memory. That's what I am intending here to do with this particular simple app. Let's go back. So what I've done, in order to learn about data structures, even to remember about the data structures, you will be needing 4 things. For any of the data structures, you will be needing its salient features, some kind of introduction, that is, a list of problems that can be solved with that particular data structure, the data structure implementation itself. This is very, very important. If you can visualize and see how the data structure is implemented inside the Python as an object or a class, then you will be able to use it very, very easily. So looking at the implementation is key. And finally, example problem implementation. These 4 things will take you a long way. Once that is done, you can engineer 4 simple prompts to get the above points for all the 27 data structures. Not 1, not 2, all the 27. And that is how I had built this app. And I'll be sharing you all the data that I had collected. I mean, at the end of the day, it's collected directly from the large language models. And these large language models have trained from the various data that has been taken from the internet. So it's only fair that we share it back. Let's go back to the discussion. Moving down, we are going to use this 4 prompts with the 27 data structures on OpenAI GPT 3.5 model. For this, I'm going to use Python for loop and file operations. So you see where this is going. The idea of having going through all this problem solving in the perspective of missions is very, very important, because we are trying to get the missions to do our work, not by ourselves. So I'm going to collect all the 27 data structures, convert them into list, and then I'm going to loop it over the Python for loop, and then store the data that is coming from the OpenAI back into the file. It's as simple. So you see that I am generating and storing the data in 4 different text files for each of the prompts. I'll be showing you the prompts and also the script. After that, we need to process the text files. So this is where the issue will start, because you are going to have 27 data structures, all the data stored in single file, and you have to segregate it. You have to extract the data that you want, for example, implementation code, and then you have to place it in a different file. So that is where Python lists and dictionaries come into picture. And the Json module, it's a supporting Python library that is already inbuilt. It comes with Python installation, so you don't need to do any pip installation for this. And using that module, you can you can process the text files, and then you can create the Streamlit app with the generated data. That's where this particular app comes. So the app that you're seeing here, this app is powered by Streamlit library, or if you want to call it as a module, go ahead. And this particular library can help you to create the front end and the back end at a little less than 50 to 25 lines of code. That amount of code you can generate this entire app, and finally you can share it with the community, like the way I am doing. You can share the entire app with the community on the Streamlit cloud. All these things we will be diving into in next couple of minutes. The idea here is not to walk you through the entire code itself, because that's going to take a lot of time. My intention here is to show you what is possible. You can take a look at the code. I believe that you should be able to understand the comments as well as the ideas that is implemented in the code. So with that said, let me open the code. There are 3 scripts that we are going to discuss in next less than 5 minutes. So that's my target. The scripts are ds_problem_solution.py, which is going to extract the data structure information from the OpenAI endpoints. Second, we have the data cleaning. We have the data cleaning file, which is going to take the text files and it is going to extract the data. And finally, we have the Streamlit app itself, where this particular app that you are seeing here is getting created. And all this code that you see here, all the scripts has been written manually. It is not taken from OpenAI. It has been manually written. The idea here is that OpenAI can actually do these things for you. The ChatGPT can do this, but the way it will do it will be completely different. So that is one of the major reasons why I had used my own ideas to come up with this particular scripts. Beginning, let us start with the problem_solution.py. This is going to extract the information regarding the 27 data structures that I have made it as a list here. And then it is going to apply these 27 data structures on these 4 prompts. You see these 4 prompts. These 4 prompts is what I was talking about here. So for the salient features, there is a separate prompt. For list of problems it can solve, there is a separate prompt. Just a second. And for the data structure implementation and example problem implementation, all have separate prompts. That is what you are seeing here. You can actually look at the prompts also, provide the various problems that the above data structure can solve. Make the output into a dictionary of problems and short description. So I'm asking you to make it as dictionary. However, ChatGPT does not return it as dictionary. It just returns it as text document. In certain cases, yes, it returns it as dictionary, but not for all the cases. Second, for the salient point, provide a precise introduction and 5 distinguishing factor of a data structure. Make the introduction less than 25 words. I am actually constraining it, and the distinguishing factor has to be less than 40 words. Ensure that the subheadings and the description are in the same line. So I'm giving the next prompt for getting the introduction about the data structure. Third, I'm asking it for a simple Python implementation of the about data structure that I am discussing about. So when I'm saying about data structure, this particular prompt is going to be common for all these data structures that I'm going to loop through. And finally, we have the solution code, which is the most frequently solved problem using the about data structure. I'm asking this question to the OpenAI: provide that problem statement, solution explanation, and Python implementation. All of these things I'm asking it to OpenAI, and I'm asking it to generate it back to me. Once I am done that, once this prompt is ready, all I need to do is call for this particular function. This particular function is going to call the chat completion chat completions.create endpoint inside OpenAI SDK, and then it is going to send the response back. The prompt is what we are created here, and the message is what we will be seeing at the bottom. So let me scroll down further. Here, for each of the prompts, I am going to create separate text files. This is going to create a separate text file called a salient point of data structures. This is just an example I'm going to show it to you. And then I am going to loop through all the 27 data structures you see here. And then I am going to send that data structures using this particular simple message that data structure is the data structure name, and the prompt will be the salient point, this particular point. Like this, I'll be doing it for all the 4 prompts, and I'll have 4 different files. The key point here that I wanted you to look at is this particular word. Whenever the data structure is used and queried by the to the OpenAI endpoint, output has to be labeled. The output is labeled here as data structure, and the data structure name is provided, and then the output that is received from the OpenAI endpoint is written after that. So in this way, what will happen is I can use this particular word to split the data structure, split the text data that is coming out. Like this, I would have created 4 files. Next is I'm going to do the cleaning. Cleaning is where the things gets little more challenging, because when you look at the output of the text files, it will be very, very confusing, because I am asking the output for 27 data structures, right? And it is going to loop through all the 27 data structures, and it's going to write it to the file. So let me share you the file for a second. So here is one of the text files, salient point of ds.text, and this particular ds.text file has the data structure, the name, and then there is an introduction. And similarly, there is a data structure, the name of the data structure, and the introduction. It keeps on doing this. Okay, in certain cases, you'll see that after the introduction, there is an additional line, and after that, there is a couple of bulleted points. In certain cases, the additional line is not having breaks in it. It is in a single line. The bulleted points are in a single line. If you are working with dictionaries, then you might actually find that in couple of outputs will have dictionaries also. These kinds of modified output are pretty normal when you are going to work with the ChatGPT or OpenAI generations. Once you look at this data, then you can think about how to split this text document, and then how to take out the data structure name and the content. So this is the content we are after, correct? We have to take the data structure name and this content, and then we have to move this to a separate JSON file. So that's what this particular file does. I am not going to explain this file. I want you guys to review this, and I'm pretty sure that the comments as well as the process that I have followed can help you to do it in no time, right? And the code as well as the file is already provided. Third is the data structure with AI. This particular script is going to create the Streamlit app. Streamlit apps are the most easiest way of sharing ideas. And here I am going to use the DS list, that is a data structure list that I have in the DS problem solution script. I'm going to use the same, and I am going to use this little step here to locate the complete ds data JSON. So this is required. This step is required if I'm going to deploy this app in Streamlit community cloud, because I need to locate this complete underscore ds underscore data dot JSON inside the Streamlit community system. So that becomes a challenge. So I had to use this process, and inside the Streamlit community system, my entire code base is inside mount underscore mount slash source, and from there it has to locate this particular file. This is one of the challenges that you will have to resolve. And then once the file is opened, from there it's simple case of loading the data, and then using the radio buttons to select the data structure. And once the data structure is selected, I have to just use the data that is present in the complete ds data JSON and populate the entire details of the data structure. I am giving a very high level overview. I know this is very different way of introducing stuff, but see, at the end of the day, this is an idea that I'm sharing, and I want you guys also to learn. And the more you are trying to practice these kinds of ideas, and if you come up with new ideas, we can all develop together. You can see that I have done a couple of changes here, and because of this, I'm able to get a very good output here. So if you don't have those triple ticks and then the Python, you will not be able to get these kinds of sections inside the Streamlit app. So that is required for that, because it actually tells it is a code. So this particular 3 ticks and Python actually tells that this particular data which is following is a code information. Excuse me. Finally, what happens is that once all these things are applied, and once we do a Streamlit run with this data structure with AI.py, you will be able to get this particular output. One thing that I want to share before I close this is to look at this particular data.json file. So let me do that. The complete data.json file is actually a nested dictionary. So it's a nested dictionary of data structures names with the 4 key value pairs. The 4 key value pairs are common and constant. So you see Python implementation, which talks about the implementation of that particular data structure. The salient point introduces the data structure. The solution implemented provides one of the solution for the problems that you can use to solve with the list data structure. And finally, the problem solved lists the various problems that the data structure can be used to solve. So all these things are present here. You can take a look at it, and you will get the output for all the 27 data structures here. So that's how we can actually get the things done using the missions. Like if you want to get the missions to work for you, you have to learn how to get the things processed by the machine. So in order to process, you have to code. So that is where Python for loop, as well as file operations, Python lists and dictionaries, and most importantly the logic of implementing Python problem solving comes into play. I believe that we have seen a lot of things in this discussion, right? We have taken a look at how to really start working with prompts, not just depend on OpenAI endpoints or the ChatGPT interface to give you all the information. You have to learn to document the outputs. Then you also have to understand how to implement Python scripting on the output that the LLM provides. LLMs are just good at text generation and auto completion. They are not at all good at idea generation, and they are not really connected to the internet. Even if you try to connect it to the internet, they are only looking at a very, very less amount of information that it can use. So keep these things in mind. You have to have the mindset of teaching machines to solve problem. So once you have this mindset, then you will think from the perspective of machine, the code that you're writing or the programming language that you're working with. We saw that how to work with the list of data structures, and then we went through this entire process of creating the prompts, looping through all the data structures and getting the output from the OpenAI endpoints, uh, storing them into the text files, processing the text files using a separate script, creating the Streamlit app, and then finally sharing it with the community. So creating the Streamlit app, sharing with the community, I've not delved into it. There are lots of discussions on that, but the app idea, you can actually find it in the code. So with that said, I believe that you have learned quite a lot of information here, even though the entire background of it is still you have to research and find out, you have to read a lot of code, but it's going to be pretty interesting. With that said, I would like to leave with 4 words, that is practice, practice, explore, explore. See you guys. Have a great time.